This is a video going through the test review for Pre-Calculus Unit 3, Topic 1, Part 1 of our trig values and using the unit circle and the special right triangles. Find the exact value from this point. So first I'm going to draw a little picture. -3, -5, and then I need the r value, x squared plus y squared equals r squared. So the radius is the square root of 34. So we have sine, cosine, tangent, and then all the reciprocals, cosecant, secant, cotangent. All right, sine is y over r, cosine is x over r, tangent is y over x. And now let's fix these up. Square root in the denominator, I'm going to rationalize that, and we get -5 root 34 over 34. Same thing here. And then negative divided by negative is positive. For the reciprocals, I'm going to use my original fractions. Cosecant, so that would be root 34 over -5. Secant, root 34 over -3. And then 3/5. Negatives in the denominator just looks funny. I'm going to move that to the numerator for my final polished answer. All right, repeat that for number 2. Over 1, down 5, x squared plus y squared equals r squared. So the square root of 26. Sine is y over r, cosine x over r, tangent y over x. Let me fix these up. Rationalize the denominator. And we can simplify that just to -5. All right, reciprocals. This is going to be root 26 over -5, so negative root 26 over 5, root 26 over 1, or you can write just square root of 26, and here, -1/5. All right, find the exact values. 3 pi over 2 is here. And pick a radius, any radius. I like using 1. So this point is over 0, down 1. I picked a radius of 1. So we got sine, cosine, tangent, cosecant, secant, cotangent. All right, sine is y over r, cosine is x over r, tangent is y over x. This is -1, this is 0, this one's undefined. reciprocals, -1, undefined, 0. Oh, 5 pi over 2, that's more than one rotation around, so I'm going to take away a rotation, but I need a common denominator. So we get 5 pi over 2 minus 4 pi over 2. So 5 pi over 2 is coterminal with 1 pi over 2 up here. I'm going to pick a radius of 1 again. All right, sine is y over r, cosine is x over r, tangent is y over x. All right, simplifying. Oh, that's floppy. All right, if cosine, which is x over r, has a terminal side in quadrant 2, what are the exact values of everything else? All right, so let's draw that. Cosine in quadrant 2 is x over r. X squared plus y squared equals r squared. So this leg is square root of 3. All right, so we've got sine, cosine. I know it says the other values, but I like to put cosine because that will help me when I go to find the reciprocal of secant. All right, sine is y over r. Cosine they gave me. Tangent is y over x. I'm going to simplify that. All right, all our reciprocals. I'm not going to have enough room. Move them over here. All right, so cosecant is 2 over root 3. Secant is 2 over -1. Cotangent, -1 over root 3. So simplifying, we get 2 root 3 over 3, -2, and negative square root of 3 over 3. Oh, another one. All right, sine, which is y over r in quadrant 4. I know this is going to be 1 because we had the same values up there in number 5. It's also our special right triangle. So let's write out our ratios. So cosine is x over r. Tangent is y over x. Nothing has to be simplified, so let's reciprocal. When I'm reciprocaling, no, that's not the right way to say that. When I'm taking the reciprocal of a negative, you put the negative in the numerator. That's the nicer looking location. All right, sine is y over r again, and now we're in quadrant 3. So I got y, r, x squared plus y squared equals r squared. Squaring a square root means multiply by itself. Squaring means multiply by itself. So when you square a square root, it undoes itself. That's their inverses. And negative times negative is positive. So we get x is root 2. But we're to the left of the origin, so we need the negative there. I recognize this. This is our pi over 4 triangle. All right, so cosine is x over r. Tangent is y over x. Anything divided by itself here, that simplifies to 1. That's a crazy looking theta. So when I reciprocal 2 over root 2, I get that radical in the denominator. I don't want to do that. Since I recognize this as the pi over 4 special right triangle, I can write my legs as the 1s and the radius as root 2. So since cosecant is r over y, now I've got root 2 over negative 1, which is negative root 2. If you reciprocal here and rationalize the denominator, you get to the same location value of negative root 2. When I reciprocal 1, that's still 1. So you can pick your preference. If you want to rewrite the triangle or you want to reciprocal and rationalize, both ways work. All right, find the exact values. I'm going to draw a triangle, label it, write the ratio. Negative 5 pi over 6. I'm going to think of pi as 6 pi over 6. Negative means go clockwise. That puts my ray here. Pi over 6 across from pi over 6 is 1. The other leg is root 3. The radius is 2. Don't forget your negatives. Sine of this picture is y over r. Well, 13 over 3 is more than 2 pi. So I want to take away a rotation to figure out where that is. I'm going to have to take away another one. Oh, that's pi over 3. It's in quadrant 1. So with pi over 3 here, this leg is root 3, this leg is 1. Cosine is x over r. Tangent, pi over 2 is quadrantal. I'm going to pick a radius of 1. So this point is over 0, up 1. Tangent is y over x. That's undefined. So pi over 3 is my reference angle. So if I label my circle in the appropriate common denominators, 1 pi, 2 pi, I see that 5 pi over 3 is almost 2 pi. Pi over 3 is my reference angle. So I can label my legs this way. Wait, that's a little squishy. Hang on. So this is down root 3. Cosecant is the reciprocal of sine, which is r over y. So that's 2 over negative root 3, which is the same thing as negative 2 over root 3. Then I have to rationalize. So negative 2 root 3 over 3. (17 over 6 is more than 2, because I know 2 pi is equivalent to 12 pi over 6, because 12 over 6 is 2. So finding my coterminal angle, that's 5 pi over 6. So in common denominators, this pi is 6 pi over 6, 2 pi is 12 pi over 6, 5 pi over 6 is a little less than 1. So my reference angle here is pi over 6, so this leg is 1, the radius is 2, the leg on the bottom is a negative root 3, because we're to the left. Secant is the reciprocal of cosine. Oh, it's the same answer as the one before. Negative 2 root 3 over 3. Negative pi over 4 means go clockwise pi over 4. Finally got the other triangle. 1, 1 root 2. Cosine is x over r. Rationalizing that, I get root 2 over 2. All right, 3 pi over 4. So I've got pi, 2 pi, 3/4 is here. 1, 1 root 2. Tangent is y over x. Negative 7 pi over 6. So this would be negative 6 over 6. So going a little further into the second quadrant is negative 7 pi over 6. So with a pi over 6 reference angle, this is root 3, this is negative 1, sine is y over r. So every single one of these questions, you have to go through all those steps to get to your final answer. Secant, negative 7 pi over 4. Well, I know 8 pi over 4 is 2 pi. So negative 7 pi over 4 will go clockwise almost 2 pi. 1, 1 root 2. Secant is r over x. Cosecant, 5 pi over 4. So here's my common denominators for pi and 2 pi. 5 pi over 4 is a little more than 1. So here's this ray is 4 pi over 4, so a little bit past that. This is my angle of rotation, 5 pi over 4. Oop, don't forget your negatives. Cosecant is r over y. All right, 4 more. Here we go. 7 pi over 4 is almost 2 pi, almost 8 pi over 4. Cotangent is x over y. Ten pi over 3 is more than 6 pi over 3, because 6 pi over 3 is 2 pi. So we get 4 pi over 3 as a coterminal angle. So this ray is pi, this is 2 pi, 4 pi over 3 is a little bit past 1 pi, pi over 3 reference angle, root 3, 1, 2, negative, negative. Secant is r over x, negative 2. Negative 5 pi over 2 is more than one rotation. So I'm going to add a rotation back. So that's negative pi over 2, which clockwise goes down here. I'm going to pick a radius of 1. Tangent is y over x. That's undefined. All right, a pi. I'm going to pick a radius of 1 again. So this is to the left 1 and up 0. Cotangent is x over y. Negative 1 over 0, also undefined. Check the boxes that have any angles that are equivalent to negative root 3 over 2. All right, so let's draw these out. 4 pi over 3 is here. Pi over 3 reference angle. Negative root 3, 2, and negative 1. So sine y over r, yes, that is negative root 3 over 2. 11 pi over 6 is almost 2 pi, which is why it's in the fourth quadrant. Pi over 6 gives me these legs. Tangent is y over x, that is not negative root 3 over 2. Pi over 6 is almost 1 pi. Pi over 6 reference angle. Cosine is x over r, yes, negative root 3 over 2. Sine of 5 pi over 3, it's going to be the same triangle but in a different quadrant. It's almost 2 pi. Sine is y over r, so yes, that's negative root 3 over 2. If sine with a reference angle of pi over 3 is giving me the root 3 over 2, a reference angle of pi over 6 with sine will not. So I'm not going to draw that one out. I automatically know that's not going to be a negative root 3 over 2. 2 pi over 3, that's a possibility. It's the same reference angle. But 2 pi over 3 is in quadrant 2. And sine in being y over r, that's a positive root 3 over 2, so that's not equivalent. Let's try one more. Negative pi over 3. Y over r, yes, that is equivalent. So make sure you can do this entire review independently and confidently, and then you are ready for the test.